YouTube. It didn't work. So this time, hopefully, I will be able to upload the video. Now, this PowerPoint is really important. We started with the research methodology, empirical research, and then the difference between theory and hypothesis. Anybody still remember what is the difference between a theory and hypothesis? Which is broad and which is concrete and specific? A theory and hypothesis. Which one is a specific prediction? Theory or hypothesis?
Hypothesis.
Good. Hypothesis is a very specific prediction. A theory is kind of broad. From one theory, you can get many different hypotheses. And we talk about variables, the different variables. Remember the numerical variables, the categorical variables, nominal variables. Nominal, that's a good word. Nominal names. The rank order variables, and then, well, the equal interval variables. And these are the raw materials for doing research. And then we talk about descriptive research. Descriptive research, you just describe what you observe. You're not trying to explain anything. It's observational. See somebody trying to get in? No, nobody in the waiting room. And these are really the most rudimentary research, case studies, surveys, and naturalistic observations. These are the different descriptive research. Today, we're going to get started with correlation research, correlation coefficients, scatter plots, and you know, I posted videos. The videos, let me show you the videos here. This video, this little video series is really important. These little videos go together with the slides, and it explains everything about the slides. If you click on, well, I have altogether 9 clips, 9 bit. No, I don't want to see you. So these are really important videos. It explains everything about the on the slides. Oh, somebody trying to get in. Let them in. You want to watch all these videos really closely. And today, let's get started with correlation research. And I'm not going to repeat what I have said in the video. You can watch the videos, but I'm going to give you an example, demonstration of correlation research with an example. And this demonstration is a real research. Here, you have the report card on BC's elementary schools. This is published by the Fraser Institute. And this is called applied research. Applied research is different from basic research. And we talk about this in week 1 in the first week section. Applied research is directed to solve particular questions, specific questions, very useful. But basic research is not directed by any questions. It's just curiosity. For example, if I'm studying anybody not here? Good morning. Yeah. Okay, if I'm studying why many people are left-handed, most people are right-handed. Why most people are right-handed, but only few people are left-handed? Well, I'm not trying to solve any problem. I'm not trying to cure any diseases or improve school performance. I'm just curious. That's a basic research. Here, we have a very specific applied research. Are BC elementary schools doing well, or are they not doing so well? And suppose if you are a parent, you have a young child, which school do you want to send your child to? Are all the schools equally good? Are they all equally acceptable? That is a very applied question. And the people at the Fraser Institute, they study the different schools and they have a report card for every school. And where do they get their report numbers? So let's look at what they measure. Here, first of all, you have a school name. How many different schools did they study? They studied all the schools in BC, 800. Altogether, they studied 878 schools, and each school got a rank. So top is number 1. And this guy, Holy Cross, this Burnaby in Burnaby, and this school ranks pretty high, 26 out of 870. Is that good rank? That's good rank. It's not number 1, but pretty good. Top 50. And that's good school, so you know. And then how about this one? Next school, Maywood, also in Burnaby. And what's rank? 657 out of 870. Is that good rank or poor rank? Poor rank, close to the bottom. And so this one, 2nd Street in Burnaby, the rank is 689 out of 870. Oh, that's even poorer, lower. So the larger the number in the rank, the lower is the school's ranking. Oh, well, the smaller is the number, the better. So this is better number. And so that's a variable. Rank, is that an equal interval variable? It's a numerical variable. 26, 657, 689 is numeric. But is it equal interval or is it rank order variable? It's a rank order variable. Number 1, number 2, up to number 870. So one variable is good. That's good. And then another variable is they start as different schools. This one is Holy Cross, Maywood. The different schools is a variable. Different schools have different names. Anybody can tell me the school names of the different schools? What variable is that? What kind of variable is that?
Oh,
Say again.
nominal.
Good. Nominal. That's names. Nominal means names. That's a categorical variable. And then different cities. So all these schools are, they group them by cities. Burnaby, and they have Coquitlam, Vancouver, etc. That's another categorical variable or nominal variable. And then here, Holy Cross, independent. Well, another name for independent school is called private school. So on the other hand, Maywood, public school. 2nd Street, public school. So these two public schools, just eyeball these two schools, they rank low, 650, 680. But this independent school, this one is a Catholic school, and it rank high, 26. So do I see a pattern? It seems that independent schools do better than public schools. But is that true for all the 800 schools? We could check that. Good, rank order. Yeah, so that's we have independent and public schools. This is also a categorical variable, nominal variable. And then we need some numbers. We need some numerical variables. And the most of the ranking is based on academic performance, test scores. The BC province, the provincial Ministry of Education gave the school students tests every year. So grade 4, we don't care about grade 4. Grade 4 is too young. Let's talk about grade 7. Grade 7 average score. So the province tests them on reading, writing, numeracy. And let's look at 2021. So this is top ranked school, 26. Let's look at the 2021 reading score, 643. Is that high or low? And then you can compare it with the public school. So this one ranked low, Maywood. Maywood, their grade 7, like a reading score is 477. Oh, that's a big difference. The difference 200 points. Wow. So suppose if you send your kid to Maywood and her reading score is 500, she will be happy because she does better than the average. 500 is better than 477. Her school average is 477. But then if she goes to Holy Cross, she got 500, she will not feel so good because she's below the average. The average of Holy Cross, 643. Wow, that's too bad. And the two schools are not equal. And you see this one, Second Street, reading 463 is lower. So that means that, well, the schools are not equal. They have different academic performance. Reading score differs. So the reading score, what variable is that? Is that a rank order, equal interval? Equal interval. So we can assume the interval is equal. If your score is 643 and my score is 644, I'm 1 point higher than you. If somebody is 645, he or she will be 2 points higher than you. So the increment intervals are equal. And these are the key numbers. Reading, how about writing? This high ranking school, 26, the writing score for grade 7 is 750. But how about Maywood, 661? The difference is big, almost 100 points. Numeracy, Holy Cross, 603, and Maywood, 500. 504. That's 100 difference. Well, that's give you a big problem. The schools are not equal. Some of the students are high academic achievers, some are low academic achievers. And then, so what do you conclude? And then these are the descriptives, describing. We're just describing what we observe. And these are the descriptive statistics. Let's analyze it. Let's analyze it a little bit. So I have all the data entered in a spreadsheet. This is not Excel. It looks like Excel, but it's a statistics software. It's free. If you're interested in having it, you're interested in learning how to use it, talk to me when we return to the in-person class. So I'm going to show you where to get it, how to install it, and how to use it. Let's analyze some of the statistics. First up, let's do the frequency. So the textbook explain all these differences about frequencies, means, but I'm going to do the demo here, demonstration. So let's look at a city, frequency, type of schools, and what else? Let's do this two first. I don't want this because they are, you don't get means for these variables because they are not numbers. They are nominal. And then so here, different cities. Still, these are the lower mainland cities. A lot of schools in Vancouver included in the data. I got 62 schools from Vancouver. Zurich, 60 schools. And then Richmond has 35. North Vancouver, 30. Burnaby, 32. And these are the frequencies. So frequency means how many times you get a school from Burnaby, 32. And then here, type of school. Independent schools, oh, I have 13, that is invalid. So I must have enter the data wrong. So independent schools, 75. And public schools, 228. So most people go to public schools. Only a few people go to independent schools. 1 in 4 go to independent schools. Independent school, they charging money. It's not free. And that's one analysis we can have. Another analysis we can have is, so if you look at the grades, let's look at Holy Cross. They have high grades, high reading, writing. And here, something interesting. The school characteristics, a characteristics that, what is a variable? Anybody remember the definition variable? A variable is a characteristic that takes on different values. And here's one characteristic. EEL students, English language learning students. That means these students are taking English remedy courses. Most likely, the students are immigrants. English is a second language, so they need to learn, take additional courses to improve their English. This school, Holy Cross, have now 0%, but look at Maywood, Burnaby. 62% of students are taking English supplementary courses. And then this one, 2nd Street, Burnaby, 38% takes English learning courses. Does that relate with their total reading rates? So one potential theory is maybe the schools with a lot of English as a second language students would tend to have a lower reading rates. That's a theory, but I don't know. And then what would be a hypothesis? From a theory to a hypothesis. Hypothesis is prediction. So if my theory is correct, my prediction is among these schools on the table, those schools with higher percentage of EEL students would have lower reading rates. I can test that. I'm going to show you how I test that. But there's another thing that is very interesting. Special needs students. So what's another term? What's special needs? Students who have special needs. These students are most likely to have so-called learning disabilities. They need special help in their school. For instance, some students have like ADHD, attention deficit, hyperactive like disorders. Some kids have dyslexia. People with dyslexia would have a difficulty reading words. You see, Holy Cross, 3%, 3.6% have learning disabilities or special needs. But this rule, almost 10%. And this one has 13%, almost 14%. So that's a variable. OCD, yeah, OCD could be. OCD is more serious. Obsessive compulsive disorder. Special needs usually related with learning skills. So we could look for relations. Does the percentage of special needs students relate to reading? That's a correlation research. And then among these 3 scores, you can look for correlation. Reading and writing. Reading and writing. Are they highly correlated with each other? They are. Let me show you how to look for correlations. First, I'm going to show you some graphs. Graph. Remember this word. I'm doing a scatter plot. Scatter plot. I'm going to show you where in the slides I talk about scatter plot. Yeah, here's the scatter plot. I'm going to get a scatter plot for reading and writing. For scatter plot, you have x-axis and y-axis. Say x-axis reading, grade 7 reading, y-axis grade 7 writing. Are they highly correlated? Here. Oh, that's really interesting. So x-axis grade 7 reading score from the very low 350 below 650, maybe somebody 700. And here writing 300 really low, 900 really high. So what do you see? Each dot is a school. This school has high reading score. It also has high writing score. And this one, high reading, high writing. But look at this one, low reading score, also low writing score. And each dot is a school. You see, those schools that have high reading score also have what? High writing score. Those schools that have low reading score also have low writing score. And if you eyeball, you look at the pattern, it's a linear. It follow a line, follow a straight line. So we see there's a linear correlation between the 2 variables, between reading and writing. In this correlation, does anybody know, is it positive or negative? Do you see a positive correlation or negative correlation? Positive, because somebody know the answer. Positive, good. Because why is it positive correlation? As the value on x-axis increases, what happens to the value correlation? Yeah, what happens to the value on the y? Also increases. As value on x decreases, the value on y also decreases. So the 2 variables move in the same direction. That is a positive correlation. Writing and reading has a positive correlation. And that is pretty strong correlation. Pretty strong. X is also to y. Yeah. And when we talk about intelligence. There are different types of intelligence. Reading and writing are both linked to linguistic intelligence. That's language abilities. Language abilities are related to each other. But how about mathematics? So writing and reading, these are related. How about numeracy? So do schools that have high reading scores also have high math or numeracy scores? I think so. Well, but let's try and look at the pattern. Analyze the data graphs, scatter plot, x-axis, let's keep it to reading. But now the y is numeracy. Numeracy score. Oh, still strong positive correlation. So these schools have high, super high reading score. They have super high numeracy score. This school, I don't know what school it is. It's a really low reading score. It has really low numeracy score. So the two variables vary in the same direction. As the value on reading increase, oh, this is outlier. So this one is not following the pattern. This one, so for most of schools, as the value of reading score increase, the value on numeracy score also increase. But there are a few oddballs. For this one, has okay reading, but really low math numeracy. And for this one, high reading, low numeracy. Maybe there's a mistake in the data entry. I will check. But this one are outliers. All the other schools follow the linear pattern, follow the linear trend. That's a positive correlation. Pretty strong. So these are the correlated. And then let's look for some negative correlation. You have the ranking. The lower the number, the better the school. So here, Holy Cross ranked number 26. This one, John Knox Christian, it's not bad. 72, top 100. Seems the independent schools are doing really well, better than public schools. That's one variable, rank. And this variable is also interesting. Overall rating out of 10. Each school gets an overall rating. 10 is really good, 0, really bad. So here, the top ranking schools, this one has good rating, 9.5 for 2021. But what about like Maywood, low ranking, poor ranking? Overall rating is half as high as Holy Cross, 4.7. Wow, that's really big difference. So one prediction is schools that have good ranking, top ranking, would have high rating. But schools that rank close to the bottom, they would have poor overall rating, lower overall rating. So I'm going to look at that and graph, scatter plot. So the x-axis, I'm going to get rid of both. The x-axis, let's see, school ranking. And the y-axis is school rating. rating out of 10. And then see what we have. Oh, here's what we have. First of all, is that a strong or weak correlation? Strong or weak? Strong, super strong. It follows a clear line, and the dots are very close to the line. They follow the line. Only a few schools deviate from the line. Almost all the schools are on the line. These are the outliers. That's a super strong correlation. The closer the dots to a line, the stronger it is. And is this a positive or negative? You just look at the graph. That's a negative correlation. So as the value of ranking increases, so the ranking, the larger the number, the better or the worse. The worse. 800 will be the close to the bottom. Number 1 will be the champion. Top 100, top 200, top 300, and then top 400. So the schools rank on top with lower numbers on ranking, they have a higher rating. On the other hand, the schools that have larger numbers on the ranking, they have lower ratings. That is a negative correlation, super strong negative correlation. As the value on X increases, what happens to the value on Y? Decreases. That's why this is a negative correlation. And then let's look at another negative correlation here. One interesting variable is special needs students percentage. Some schools have a very high percentage of special needs. This one, Second Street, Burnaby, 13%, almost 14%. But some schools have really low. Our Lady of Mercy, special needs students, less than 1%. Are there higher numbers? 6%. This one, the 6.8%, 12%. 8%. So I'm going to do a correlation between special needs students and maybe reading. Let's look at a scatter plot. Special needs students here, X, and let's see, numeracy. How about numeracy? Grade 7 numeracy. Here you are. First of all, do you have a weak correlation or strong correlation? Strong or weak compared to this one and this one? It's weaker. You see a line, you see a linear trend. So the general trend is the schools, these schools have a high percentage of special needs students, 18%, 16%, and they also have a lower grades on numeracy scores. And these schools, generally speaking, here, they have a lower percentage of special needs students, and they tend to be having higher numeracy scores. So overall, you have a negative correlation. Yeah, weak. Yeah, but really weak because here, these schools have a zero special needs students, but some of them also have a low grades. Some of them have high grades. Although most schools show a linear trend that is negative, weak negative correlation, you can still see a correlation. And then what would a really weak correlation look like? Let me show you a really weak correlation. So suppose I'm analyzing, let me show you here. EEL, the percentage of English language learning students, and some of them have a lot, like Taylor Park, Burnaby, almost half students, 45% students are taking English language classes. And does this variable relate with reading? I mean, do international students show lower grades, like immigrant students show lower grades on reading? I'm not sure, so we can do that. EL, let's see EL students. Let's just show reading first. That's a correlation. Oh, do you see any correlation? No, there's almost no relation. Why? Why not? So you see here, these schools, they all have 10% English language learning students. Some of them have poor scores on reading, but some of them have high scores on reading. And then these schools, 50% students take EEL classes. Some of them have poor reading scores. Some of them have high reading scores. So it doesn't matter. It doesn't matter what percent of English language students you have. Some schools have a lower scores on reading. Some have higher. There's almost no relation between percent of students who take English language classes and the students who are other schools who are doing poorly or better. So almost no relation. So here, this is almost no relation, really weak. And this is weak negative correlation. Here, you have a super strong negative correlation. And what is this one? Strong positive correlation. Strong positive correlation. Correlation research gave you a lot of good information. They tell you which variables are related with which. Reading related with writing. They move in the same direction. Reading is strongly related with numeracy. They move in the same direction. Schools have high reading scores, also have high writing scores. And then school ranking, super strong negative correlation with school rating. Those schools are ranked to the bottom, they have lower ratings. Those schools who are top 100, they have high ratings. Here, special needs students have somewhat kind of a weaker negative correlation with numeracy scores. And these are the correlation studies. These are the scatter plots. Okay, let's take a little break. Let's take a 10 minutes break and come back. I'm going to explain more about correlation. Okay, let's get back. There are two ways you can show a correlation. One way is using the scatter plot. Another way to show the correlation is to use a number. That is a correlation coefficient, the R value. A number close to 0, R equal to 0, will be closer to no correlation. There's no relation between the two variables. Okay. This one, correlation between the percentage of EL students and reading score, that would be close to 0. But it's hard to get a real 0 correlation. Everything is correlated with everything else. Let's do the calculation. I will calculate the correlation coefficient of this one. Percent of EL students are reading. Correlation bivariate. Bivariate means two variables. I'm correlating two variables. So EL students and what else? Say EL students are reading, grade 7 reading. Oh, EL students, grade 7 reading score. Here the result is negative 0.43. So it's kind of weak, but there's still a trend. It's weak, but there is a negative trend. So it seems that schools who have a higher percentage of English second language students do tend to have a lower overall reading scores, but the relation is really weak. How about this one? This one's stronger. Special needs students percentage and numeracy scores. Let me do that. Bivariate, one variable would be percentage of special needs students, and so students, let's see numeracy. Well, still like a weak correlation. So negative 0.35, negative 0.35. This is a correlation coefficient. Pearson correlation. And you look at this one, percentage special needs students and grade 7 numeracy. It's negative, but weak, negative 0.357. So in other words, those schools who have more special needs students tend to have lower numeracy scores, but the relation not terribly strong. This one is super strong. School ranking and school rating. And this one is going to be close to -1, -1.0. Let me see, let's get that. School ranking versus school rating. Ranking, rating. Okay. Oh, look at how strong it is. Negative 0.974, negative 0.98, almost negative 1.0. And that's a super strong negative correlation. Can it get even stronger if we don't have all these outliers? If all the points line up on the line, it will have a perfect negative correlation. Let me show you one of those from the slides. this would be a perfect negative correlation. Most times we use the small r to represent correlation coefficient. And this r equals to 1 point negative, 1.0. And all the dots are on the line. So this is your exam. Suppose we get the midterm exam done, and the full marks 100. If you know I got 90, you know how many points I lost. I must lost 10. Perfect prediction. If you know I got 70, you know I lost 30 points. That would be the strongest negative correlation. In this case, we almost have the strongest negative correlation. It's close, almost there. And then how about this one? This one's going to be kind of strong positive correlation. Grade 7 reading and grade 7 numeracy. Grade 7 reading, do the analysis, bivariate correlation. No. Grade 7 reading, that's one variable. Grade 7, let's add writing too. Numeracy. Grade 7 reading, you see here, grade 7 reading and grade 7 reading 1.0 is that strong or weak? Super strong, because these two variables are the same thing. They are the same. Let me show you another example of 1.0. When we have this kind of a correlation, it's a correlation between the same thing. So here's you have Fahrenheit temperature. United States, Americans, they use Fahrenheit. But in Canada, we use Celsius, but it's the same. If you know the room temperature is 80 degrees Fahrenheit, and then what's the Celsius degrees? You have a formula. It must be one value. And if you know the Fahrenheit temperature is 60, you know the Celsius. And this correlation coefficient is positive 1.0. Correlation between the same thing. And it's the same as a negative correlation. If you know I got 90, you know I got 10 points lost. Look at here, grade 7 reading and grade 7 writing. That is a strong correlation, positive, 0.82 or 83. Grade 7 reading and grade 7 numeracy, very strong, 0.8 positive. So those are strong correlations. Correlation coefficient, has a range from -1 to +1. So the closer to -1, the stronger or the weaker to -1. The closer to -1, the stronger. The closer to +1, the stronger. The closer to 0, the weaker. So that's the range of correlation. And then if we look at these three correlations are here. Between these three correlations, which one is the strongest? Which one is the strongest? -0.65 that is the strongest. Okay, that's what we need to know about correlations. And so I was going to do this in-class exercise. But probably we don't have the time to finish it. But we can go as far as we can until the end of the class, and then you can bring this, print it out, bring it to class. We're going to kind of finish it up from the in-person class. We're going to get started today. So this is experimental research. We're going to get started. Yes, I'm going to talk about that. Going to talk about the assignment. This is assignment, in-class exercise, and then you follow me, and then if we can't finish it today, take this to the class next time, and then we're going to finish next time. So here, let's see. Look at here. You remember to download it from the portal. Researcher believes the sleep deprivation impairs memory. He asked 10 college students to participate in a study. The study began on Monday evening. So we start a study now. Half of the participants were randomly assigned to sleep for 4 hours on that night. You only sleep for 4 hours. That's sleep deprivation. The other half of the participants were randomly assigned to sleep for 8 hours that night. And these students sleep the normal amount of time. On the next morning, all students complete a memory test on academic materials they had learned during the previous day. Each student's test score was recorded for analysis. The highest possible score was like 10, the lowest 0. Let's look at the data. So you have group 1. These people sleep for 4 hours. Subject number 1, that would be Joey. Subject number 2, that would be Mark. And each one has a test score. So well, this guy got 1 correct, very low. 3, 4. This guy got the highest, 7. And that's group 1. Group 2, you have 5 subjects, and then they all sleep for 8 hours, normal sleep. And then look at this score. Some of them got a low score, 3, 5, 6, 7, 9, and different scores. So first, how you analyze the data? First, you gotta get the mean. The mean. What would be the mean? And if you want to get the mean, first you have to get the sum. Anybody can tell me what's the sum for this group? You add it all up. Add it all up. Anybody got the sum? Yeah, I think somebody got it. Good math. Sum is 20. And then, so the mean is 20 divided by how many? 5. So that's going to be 4. Or on average, this group, remember, 4 words only. And then the median is the middle number right in the middle. So here, this guy is right in the middle, 2 below it, 2 above it. So the median is also 4. The range, what's the range? Range is the difference between, let me see somebody. Good. The range is difference between the biggest and smallest. So the biggest is 7, smallest is 1, range is 6. People differ by 6. And then that's group one group. Second group, 8 hours sleep. You add them all up. The sum would be, somebody got the sum already. Good math. 30. So the mean will be 30 divided by 5. Oh, you guys are good at math. Yeah. 6. Get, yeah, the mean 6. And then how about the median? Right in the middle, this guy is here. 2 below it, 2 above it. Median 6. How about the range? Largest one is, so something on the range already. Yeah, so the range is, the largest is 9. And then the smallest 3. Yeah, the range is 6. Good. So once you get the mean, the median, the range, you have a rough idea of the data. So is my prediction being supported? Does the data looks good? Yeah, I was predicting that the 8-hour group would do better. On average, the 8-hour group, on average, they remembered 6 words. On the other hand, the group that slept for 4 hours, they remembered only 4 words. And that's what I was predicting. And let's look at some of the questions. What were the variables being studied in this research? Yeah, give me the 2 variables. Give me 1 variable. 1 variable being studied in this case is somebody got me the answer. Score curve, memory score. So memory score is 1. And what is the other variable? Well, you can see memory performance. And then what is the other variable? The other variable is different hours sleep. This group sleeps for 8 hours, 4 hours, so sleep time. And for memory, this variable, is it quantitative or qualitative? Equal interval or rank order? Qualitative is equal interval or rank order? Equal interval. Because 1 word is a word. If I'm 6, you are 4, I'm 2 more than you, 2 higher than you. How sleep time? Sleep time is equal interval. 1 hour is an hour. So those are equal interval variables. And then what type of design that you have? This is experimental design. Why? I will explain why next time, but this is experiment because you have 2 treatment conditions. 1 treatment condition is 4 hours sleep. The other one is 8 hours sleep. Another thing it has is that random assignment. Participants were randomly assigned to sleep for 8 hours or 4 hours. The participants, they don't have a choice. And that makes an experimental research. 2 things make it experimental. Number 1, different treatment conditions, different treatment groups. Number two, random assignment. Research hypothesis. I will stop here. I'll stop here and download this. Try to see. Well, you can write it on it and try to do it yourself. But then next time, I hope we'll go back to classroom. We'll finish this off in class. We will work out the answers together in class. After we have worked out all the answers together in class, you write in the correct answer. And then you hand it in, and you will get the marks. Yeah, go ahead, Kritika. Speak up. What question you have? Hello, Kritika. You have a question? Oh, means. Oh, means. So how to copy the mean? The means is average. The average. So here, how to get the mean? First, before you get the mean, you get the sum. The sum is you add everything up. So here the sum is 1 plus 3 plus 4 plus 5 plus 7 equals that's 20. And then the mean is the sum divided by sum of all numbers. Sum mean is sum divided by number of people in the group. So the mean is 20 divided by 5. Yeah, okay. If you have questions, we can still have question and answers next time. And also watch the video. The video will explain a lot of stuff. On nature versus nurture. On nature versus nurture. Nature is genes, genetics. So if I have a shy nature, that means it's biology. Nurture means experience, nurturing. It means parents, school. So yeah, if I'm really shy, maybe my parents criticize me too much. That makes me shy. Maybe at school, I was ridiculed, I was bullied, I was discriminated. That makes me shy. Those are nurture. Nature means something about my biology, about my genes. That's a difference. Hindsight bias. Oh, hindsight bias. I will explain that next time. I will explain next time in class. Yeah.